All right, in this video, we will be going through the procedures for the virtual lab V10, that is acids and uh, pH and acid dilution. This is your virtual lab for week 9 here in Chem 106. So let's get into what that actually looks like. So we're going to start off by going here to LabArchives as usual. Now, previous video, I already covered the pre-lab and kind of walked you through a little bit of kind of the theoretical constructs. If you haven't watched that pre-lab video yet, I would strongly encourage you to do so. It's on the same channel in the same playlist here in Chem 106 Lab. We're concerned today with the procedures. And so for the procedures, we're going to go to a familiar place. This is the virtual lab simulation from Carnegie Mellon University. So I'm going to control click here on the procedures to open this new window. And I want to go to the virtual lab. And I want to open the file that is in the acids and bases folder called the method of successive dilutions. So it's this one right here. Now, the procedure itself here is relatively straightforward and simple. And again, this is a really good place where the procedure is not very difficult to do. But you're probably going to want to have multiple windows open at the same time. So here in the data results section, you can see this is where you're going to collect your data. My recommendation actually with this, since these calculations are relatively easy to do, I would move that over to a spreadsheet. So my first recommendation to you actually is to get an Excel sheet open. You can copy and paste these tables over to that Excel spreadsheet, and it's going to be a lot easier for you to work with. And the reason for that is because if you go here, you can see, okay, here's my spreadsheet. I've got everything I need. And if I use my equations properly, I can actually set things up relatively simply, just based off of, so for example, I'm measuring the pH. The pOH of that is going to be equal to 14 minus the pH. And so I can set up my spreadsheet to do all those calculations for me. And I can certainly do that down here as well, just with a simple copy and paste thing. These calculations, these are going to be done via the dilution equation. And so again, the process there is relatively simple as well. And again, you can have Excel do all of that for you. So my recommendation would be to do these in Excel and then copy and paste them back into LabArchives. That would be what I do, especially since you're gonna have to do some graphing with this stuff later on in the lab anyway. So you might as well have it in Excel so that's easy to work with. And again, it's easy to port it back and forth once you have it. So that would be what I would do. And then again, for this part here, you have the capability to just take that table, and you should be able to do this paste from Word. If you do the paste from Word, it should bring the entire table over like this. And you would have the option to put the lines back in it in your table properties. Like so. So just something as simple as that saves you the having to do some of those other things that you sometimes have to do with moving things around on LabArchives. So that would save you a little bit of time, and the calculations, it would save you from having to do all of them by hand. So that's the first kind of note I can give you on this. Now, as far as the actual procedure is concerned, you are going to be doing a series of 7 dilutions. So the easiest way to actually go about doing this, you're going to get into your glassware here. You need a cup of water. You're going to need your hydrochloric acid. And then out of the stockroom, you're going to need an Erlenmeyer flask, one just like this. Now, in this Erlenmeyer flask, you're going to drag the water over, put 45 milliliters of water in. And really, that's all that you need the water for. So I'm just going to remove the whole thing. Now, you're going to need 7 of these flasks. So instead of dragging out 7 Erlenmeyer flasks and watch the simulation get mad at you over doing that, what you can do instead is, let's get rid of all these extra flasks. You can duplicate. So I need 7 of these, so that's a 2, 3, 4, 5, 6, 7. All of them all have 45 milliliters of water in them, which is exactly what we want. And now we're just going to rename them. 1, 2, 3, 4, 5, 6, and 7. And so what you're going to do is, right now, if I click on any of these flasks, I'm going to get the exact same information. My initial concentration of hydrogen and hydroxide are exactly the same. I've got 45 milliliters of water and a pH of 7. But what I'm going to do is I'm going to do a series of successive dilutions, starting with this first one. Now, the first one here, I've got 1 molar hydrochloric acid, and you can see that the 1 molar hydrochloric acid has a molarity of 1.000 and a pH of 0. If I drag this over to the first one, I want to take 5 milliliters of that 1 molar hydrochloric acid, put it in here, and now I've got 50 milliliters of total. So I'm done with the hydrochloric acid now. I'm going to take it off the board. I've taken 5 milliliters of 1 molar hydrochloric and turned it into 50 milliliters in total. That is using my dilution equation. I had 5 milliliters multiplied by 1 molar divided by 50 milliliters in total now. And I've already set this up for scientific notation, probably a good idea because the numbers will eventually get pretty small here. My calculated value of hydronium is 0.1 or 100, 1 times 10 to the negative first molar, which matches the molarity you see here. Now, since hydronium and hydroxide are related to each other by Kw, I can set up another equation. This is equal to 1 times 10 to the negative 14th Kw divided by my calculated value of hydronium. So I get a hydroxide value of 1 times 10 to the negative 13th. And you can see that within close significant figure reasoning, I've got that value here as well. So since I've got a good formula here, I'm going to drag that over. My measured pH here was 1. So I've now filled in that line. And so I'm just going to do the same thing over and over and over, taking solution 1 and putting it into solution 2. Solution 2 now has a pH of 2. The concentration has changed. It was 5 milliliters of this solution, 5 times this solution, now divided by 50. And my measured pH is now 2.00. So if I continue on this path, 2 turns into 3, 3 turns into 4, 4 turns into 5, and so on, I'll eventually be able to fill out this entire table. And then I'll be asked to do the same thing. So that's part 1. And here, number 6 just talks about the calculations that we're doing in this table. And again, strongly encourage you to use Excel because it's going to make your life that much easier in terms of having to do the calculations by hand versus by Excel. But the calculations aren't that complicated anyway. In number 2, you're going to do the same thing using the 1 molar NaOH instead of the 1 molar hydrochloric acid. So you'll reset the entire bench. Clear workbench. You'll do the exact same thing that we just did. This time with sodium hydroxide and your flask. And again, the same kinds of things that you did before. 45 milliliters here, and then I would just duplicate this. To give me 7 total flasks. So that's what 5, 6, 7. And so you go through the exact same thing. You collect all of the same data along the way. So that's the first part of this. And again, relatively straightforward and easy. Probably won't take you more than 20-30 minutes to do and collect everything. And so make those tables in Excel. You can copy and paste them back in. The graphs here, you need to make a total of 2 graphs for each trial. The first graph is just going to be a combination of dilution versus pH. So you're going to make your standard scatter plot. You're going to do your normal kinds of manipulations to it. Understand this graph is not correct because these measured values of pH are not going to be this precise. But you should get something pretty close to this. And it says you need to put in correct axis titles and units and stuff. Thing is, pH doesn't have a unit, and the dilution number doesn't have a unit either. So you just need to make sure that you title it properly. Measured pH versus dilution number for the acid. Now, you will need to do this graph a second time with a logarithmic scale. So you need 2 graphs in total for the acid. Now, the way to turn it into a logarithmic scale is really simple, actually. So this is your normal one. So this is one of your graphs. You'll need a second graph with a logarithmic scale. All you need to do double click on the y-axis there, and we're going to go to axis options. Down here in axis options, there is a logarithmic scale button right here that will change the scale to something that is logarithmic. And that's the second graph that you need. So relatively straightforward, pretty easy to do this. And again, you'll need both graphs. For the acid, you'll need both graphs for the base as well. The other thing in the results, there are 5 post-lab questions here, and they're relatively straightforward. So number 1 is about the dilution method that we used itself. Would we have gotten different results if we had used a slightly different dilution method? The second question, write an algebraic equation for the concentration of hydronium based upon the dilution factor. This is going to be a very simple equation. Probably already have it in your notes somewhere. You just need to kind of figure out what it is. Number 3 asks you to determine the value of the exponent for the original stock solution. Number 4, for number 4, I'd actually recommend doing results number 4 while you're doing data table number 1, because you're going to have to clear the lab bench to do the base trial. And what you don't want to do is you don't want to have to recreate everything just to do that 8th dilution. So what you can do is, while you still have your acid out here, so we'll get rid of the base, we'll add an 8th flask and our acid solution. So you've done all 7 of the dilutions, you do an 8th one, you measure the pH, you explain why the pH is what it is. That's really all that we're asking for there in number 4. And then number 5, you're just explaining the results in part 2. So again, this is a relatively straightforward assignment. You shouldn't have too many problems with it. But if you do have problems, I will be in Zoom with the in-person crowd on your virtual day. Please feel free to pop into Zoom and ask questions as they come to you. Or better yet, ask questions on your in-person day, especially if you're in the Thursday group and you have Tuesday and Wednesday to kind of wrap your head around this activity. But that's all for this particular video. Again, if you have questions, feel free to reach out to me. Otherwise, have a good day, and I'll see you in lab.